Hello everybody. So this is the second video in behavioral sciences. We'll talk about the measures of screening test performance today. So let's start about how to construct a 2x2 table. So the best thing to do is to put at the top the disease, or there is no disease, and to the left side the positive and the negative. Once you do that, it's better to start with the positive or negative first, then the true or false. So let's see. So start with the positive first. So this is positive and positive, and then see, is there a disease? That's a true positive. It's a positive test, and according to a gold standard, there is disease. So it's a true positive result. While here, it's a positive test. But according to a gold standard method, these people are well. They don't have the disease. So it's a false positive result. While here, start with the negatives. So put negative here and negative here. And then see. Here we put negative, and there is no disease, so it's a true negative. While here we put it a negative first, the test is a negative test, but according to a gold standard test, there is actually a disease. So it's a false negative result. So once you are able to construct this table, it will make it very easy for you, whatever they give you. So let's start by talking about sensitivity. So sensitivity is the proportion of true positive or diseased people, truly diseased people, among all diseased. So these are the diseased people here. These are all diseased people, whether they're classified positive or they're classified falsely negative according to the test. But they are the fact that they are diseased people. So we're looking for the true positive among all the diseased who are classified correctly. So sensitivity is the true positive among all diseased people. All diseased people are the true positive plus the false negative. So one way to remember also that sensitive people are a little bit sensitive. Diseased people are sensitive. So in sensitivity, we're looking for the diseased people, the truly classified. And in the 2x2 table, they are in the left. They are in the left column. Okay. So ability of the test to detect those who are diseased, we talked about this. When there is high sensitivity, there is higher chances the test can detect people who have the disease, decreasing the false negative. So if there is higher sensitivity, we increase the ability of the test to detect those who are truly diseased, and in turn we decrease the people who are falsely classified as negative. So if you remember the formula, you can get it from the formula. Increasing the sensitivity means increasing the true positive and decreasing the false negative. So I always construct a formula and then answer any questions they ask about it, because they like to ask about how increased sensitivity affects the false negative, how it affects the true positive. So sensitivity is used mainly for screening. A high sensitive test is best for screening tests. In screening tests, we want to get all the people who are diseased, even if we get some few people who are not diseased, but at least we'll get all the diseased people. We want to get them in the screening test. Okay, We'll talk now about the specificity. So, in specificity, it's the proportion of true negative. We're trying to detect now the well people. So, the true negative among all non-diseased. So these are the non-diseased portion of people, the well people. We're trying to detect that are truly classified. So this is the negative test, and they are well. So this is the true negative among all non-diseased. True negative plus false positive. So it's the ability of the test to detect those who are well and exclude those without the disease. Higher specificity, what does it do? You can always go back to the formula. Increasing the true negative, higher specificity, decreasing the false positive. Alright? So, one thing to know that the sensitivity and specificity are fixed values. They do not vary with the pretest probabilities of the disease or the prevalence. These are measures for the test itself. So whether there is high prevalence of the disease or there is higher pretest probability, like many risk factors for the disease, it doesn't affect the sensitivity and specificity. These are related to a test. Some tests are highly sensitive and some tests are highly specific. The optimal test will have higher sensitivity and specificity, but we can't always have this optimal test. We'll talk later more about raising the cutoff and what it does, but let's mention it here also. So when we raise a cutoff of a diagnostic test, it becomes harder and harder to detect those are with the disease, the true positive results. So we'll decrease the sensitivity of the disease, but those who are detected will be the true ones who have the disease. So increasing specificity. We'll have less false positive. So increasing specificity and decreasing sensitivity. While lowering the cutoff of the point of the test makes it easier to detect the diseased people, so increased sensitivity, but we'll get some false positive results. So decreasing specificity. We'll talk about them a little bit later too. So we'll talk now about the pre and post test probabilities, the positive predictive values and the negative predictive values of the test. What's the positive predictive value? It's the probability of having the disease if the result is positive. So when we say we have a positive result and we actually have, when we say I have a positive result, it's actually a diseased person. So it's all about the positive. When we say there is a positive result, we actually have a diseased person. So it's the true positive among the all positive results. So it's the top row. The true positive among all positive results. Positive predictive value, remember the word positive. True positive among all positive. The post-test probability of having the disease is directly related to the positive predictive value. What does it mean? Let's see an example. If a positive predictive value is low, then we have a positive result, then the post-test probability of having the disease is low. Okay? What's the post-test probability? The post-test probability is also dependent on sensitivity, specificity, and pre-test probabilities of the disease. So let's talk now about the negative predictive value. It's the probability of not having the disease if the test result is negative. So when the test result is negative and we don't have the disease, that's negative predictive value. When everybody I say is healthy is actually healthy. So we'll concentrate on the negative. Go to the negative row, the lower row, and see. So the true negatives among all negative results. The true negative among all negative results is the negative predictive value. The negative predictive value will also vary inversely with the pre-test probability of the disease. A patient with high probability, for example, of having the disease has a low negative predictive value. Example, if a negative predictive value is high and the test result is negative, then the chance the patient will be healthy is high. Will be negative is high. So a negative predictive value is high, and the chances of a patient being well, a negative result, is high. So let's talk about another example. So breast cancer and FNA test results. If a patient has increased pre-test probability of having the disease, like he has a first-degree relative with breast cancer, he had old age, this patient has a low negative predictive value, so inverse relationship. The chances he has an increased pretest probabilities, the chances that he'll be negative, he'll be well, and truly classified as well, will be low. While a patient with a low pretest probability of having the disease, no family history, less than 40, young patient, this patient, if he was classified as a negative, there's a high chance that he will be negative. That means he has a high negative predictive value. Okay? The prevalence of the test of the disease is also directly related to the pretest probability of the disease. Positive predictive value, and inversely related to the pretest probability of not having the disease, negative predictive value. We're saying it in a different way here. What does it mean? If we have increased prevalence of the disease, having a positive result, and that positive result being a true positive result among all the positive, is high. So increased prevalence, there is increased positive predictive value. So a direct relation. While if we have increased prevalence, the negative predictive value becomes low. If the test result is negative, the probability of a patient to have the disease is 1 minus the negative predictive value. We'll talk about accuracy now, or validity. What's accuracy? The proportion of people who are correctly classified. In other words, the test ability to measure what it's supposed to measure. The results should be compared to a gold standard test, we said that before, to determine the accuracy. We also compare them to gold standard to determine the sensitivity and specificity also. So accuracy are the true results, true positive plus true negative, among all screened people. The true positive plus the true negative plus the false positive plus the false negative. The prevalence is the proportion of screened people who have the disease. We say this disease is prevalent. So all diseased among all screened. All diseased are the true positive plus false negative among all screened people. What's the reliability? The reliability ability of the test to give similar results if it's repeated. The test is reproducible. We want, whenever we repeat the test, to have similar results. It can be, it doesn't mean that it's an accurate test, but it's reliable. It gives the same results every time. It could be wrong, but it gives the same result. While we want it to be accurate and reliable. Okay, there is another nota bene here, that the sensitivity is directly proportional with negative predictive value. If we increase sensitivity, we increase the negative predictive value because when we increase sensitivity, we decrease the false negative. If we decrease the false negative, the negative predictive value will increase. So having the formulas will help you also to remember this. And another method is the n goes with an n, so sensitivity with negative predictive value. While specificity is directly related to the positive predictive value. If we increase specificity, if we remember, increased specificity will result in lower false positive. If you have lower false positive, then the positive predictive value will increase. So the best thing is to do multiple examples and practice this until you're comfortable with the formulas and comfortable in doing it fast. So whenever they give you an example, don't depend. If they give you a table, don't depend on the table. Make sure that they correctly classify the disease and the non-disease on the top, the positive and the negative on the left side here. Because sometimes they rearrange them in different ways and it will make it harder for you to get the results that you want. So in this example, we want to get the sensitivity. We said that sensitivity is the left column. In sensitive people are diseased. We're getting the true positive among all diseased. True positive among all diseased. So 90 over 100. Well, in specificity, we want to get the people who are well. The true negative among all people who are well. So true negative among all people who are well, 840 divided by 900. All people are well. True negative plus false positive. The positive predictive value, we're more concerned about the positive results. The true positive by all the positive, not by all disease, so by all the positive. So true positive plus false positive. So it's 90 over 150. How about accuracy? We want all the true results among all the screened results. So all the true results, true positive plus true negative, divided by all the screened. If you count these all, that's what you'll get. What's the prevalence? The all diseased divided by all screened. So these are the all diseased, and then count everything, the all diseased, the all screened. Sorry. So all diseased by all screened. So we talked about raising the cutoff. of a test. So this graph here represents the diseased, and this one represents those who are not diseased. And then, according to the cutoff they give you, anything, this is the cutoff, anything to the right is positive, and everything is to the left is negative. So if we raise the cutoff from X to Y, what will happen? So as we said previously, if you raise the cutoff, the specificity will increase and the sensitivity will decrease. To make it easier for you to get all the other information that they need, write the formulas here. So when we increase specificity, this is the formula for specificity, the true negative, divided by true negative plus false positive, or the people who are well. So if we increase specificity, we increase the true negative, and we decrease the false positive. And we also said the specificity goes with positive predictive value. So if we increase specificity, we also increase the positive predictive value. What happens if we decrease, and we also said here we will decrease the sensitivity of the test. So decreasing sensitivity will decrease the true positive, but will increase the false negative. So you're able to get this information from the graph, or an easier way to get it from the formulas, and know whether they increase the cutoff, move the cutoff toward the diseased, or decrease the cutoff, moved it towards the well. So another example here is when we lowered the cutoff from X, moved it towards the well people, what will happen? Lowering the cutoff will increase the sensitivity and decrease the specificity. So have the formulas here. Sensitivity, the true positive among all diseased. The sensitive people are diseased. So increasing sensitivity will increase the true positive and will decrease the false negative. Specificity, and it will increase also the negative predictive value. Decreasing specificity, as we said, will decrease the true negative and will raise the false positive. And because specificity goes with positive predictive value, it will decrease the positive predictive value. While sensitivity goes with the negative predictive value, so it will increase the negative predictive value. So that's it for today. Let me know what you think about these videos, and if I should continue with them, or I should change, or I should go back to the live. Thank you very much.